All right, everybody, let's get started. All right, let's get started. Happy Friday. It's the end of the day. We're so close. I'm going to open the door.
You have the podium out here. That's what we usually jam it with. Yeah.
Great. Okay, so today we're gonna finish up our work with our example on using arrays as data structures. The book has a few more examples, so if you have access to that, like examples of full programs like implementing a tic-tac-toe game and keeping track of the score on an array, things like that. So if you have access to the book, that might be a nice thing to look at, in addition to what we're doing in class, just to kind of get used to writing programs, understanding some sort of like design patterns. Okay, last time we were looking at this scoreboard, and we were trying to build this scoreboard together. So the idea being that we want to be able to initialize a scoreboard object. We want to say how many scores is it going to hold. Maybe it holds 7, so it's only the top 7 scores. And it's going to maintain an order, so the top scores first. We need to be able to add someone, so we were working together on that add method. And so for today, I wanted to look at the book's implementation of add, so it's fully finished, and we can kind of make sure that we understand that. Then we will spend some time individually or in partners or small groups thinking about how do we finish up a remove method. And then we'll look at sorting, which kind of gets us a little flavor of our sort of algorithms work that we'll be doing in the rest of the class. So if you're on here looking at this, we should be able to grab game entry, scoreboard, and scoreboard demo. I'm just going to make sure that I haven't added anything here. So I'm just going to paste in scoreboard. I think it should be the same as what's online, but just to make sure, I'll put this in here, and I'll make it nice and big for us. So I wonder why do I not run this? Okay, great. So what's in here is this finished add method. And so I guess maybe let's review our scoreboard. We've got a number of entries. So for example, if we want our scoreboard to be able to hold 7, the num entries is the current number of entries in the scoreboard. So maybe it can hold 7, but maybe we only have 4 scores in it right now. And board is an array of game entry objects. And game entry objects hold both a name and a score. So for example, I might have my current scoreboard holding Mike, who had a high score of 1105, Rob had a high score of 750, Paul 720, and a 660. And if I want to add in, say, Jill, by calling the add method, and Jill had a score of 740. Can anybody tell me where Jill should end up in order to keep this in order? Yeah, sure.
Between Rob and Paul.
Between Rob and Paul, great. And in this case, we only have 4 entries. We're adding a 5th, and we initialized our scoreboard to hold 7. So even if Jill had like a low score, like just 100, we would add that score at the end, but it would get added because we can hold up to 7 scores. But if we already had 7 scores in here, then somebody would get pushed out, right? So, okay, so we want to do this. And so just even further setting ourselves up to understand what's going on, let's make sure, let me grab, I think this is what I want to do. I want to say yes. Okay, so we had this sort of representation of our array of game entries where we have remote controls, sort of. This is like what the book likes to think of this as. But we can also just draw this as an array of pointers to scores. And how are these sizes? Is this too small to see? You can see it? Okay, awesome. So we've currently got 4 entries in here, and we want to add Jill. So let's look at our code to do this in scoreboard.java. So we've got our add method here. All right. So I think we together last time we saw, okay, cool, we're definitely gonna need to address this new score that we're getting in. So in this case, in our example, new score is Jill's score of 740, right? Now, we also talked about how we wanted to check whether we're even going to add Jill's score in. We're gonna add this new score in. And we talked about our 2 checks there. We have, is our current number of entries less than the length of our board? In that case, we're definitely going to add the score, right? So if number of entries is less than board.length, or if that new score is, so once we've made this check, if this is true, then Java is just going to jump into the if statement. It doesn't even have to check the second one. But if this was not true, like suppose my board had 7 entries in it already, then we'll check this second condition after the or. Then if the new score is greater than what? Well, than the last one. Then I need to add it. So this if statement right here, okay, so then we're in the case that we should add it. So this if statement is saying, well, if we weren't already filled up, if the board isn't already filled, then we need to increment num entries, right? Because we're going to put in another one. And what this does for us is, so once we've done this, now we can start to find, once we've done that, we need to actually move things over, right? So in this case, we're adding Jill, and we can all kind of, with our brains, we know that Jill needs to go in here, right? But to achieve that, we need to shift everyone below the new entry. In what direction? What direction would we say that we need to shift everyone? Yeah, I'm seeing a direction pointing to the right, so shift everyone below the new entry to the right. And so now comes the hard part. How do we write that in Java code? Well, let's take a look at this first line here. So what is J? In this case, can anybody tell me what value J would take here? And there's a trick, actually, I would say. In my example, if I've gotten to line 22, what value would J have? Yeah. 21?
Because if no one chooses that value, you go to this 22.
So, wait, say it again.
So integer, which is j, is going to find that.
Yep, we're just declaring and initializing an integer j.
Okay. So are you asking if I plug in this 22, we plug in 22 for j?
Yeah, I'm asking in this if my scoreboard were as it is in this example, so if the instance of the scoreboard had this state, then what value would J have? Okay, so 2 is one guess. And why are you thinking 2? Yeah, so okay, so 3 makes a lot of sense, but what, okay, but if it was 3, so, okay, let's say it's 3. Let's say it is 3. I'm going to put a question mark there, but let's say it is 3. So let's say it's 3. Now, what's going to happen when I try to call board at, like, how, if I start at 3, then I'm going to compare Jill, so that's my new score is Jill's score. I'm going to compare Jill to J minus 1, right? So then I would be comparing to 2 first. But then I would kind of never compare to Anna, right? I would only move Paul over and not Anna. So actually, if we look at this code closely, once we get to line 22, we would actually have, in this case, incremented num entries to 5. And so J would actually be 4. Oopsies. J would be 4. And so then what we would do in this while loop is we would take a look. Okay, we would say, what's J minus 1? It's 3. So is my current score 740? Greater, is it less than 660? Let's see. Oh, no, sorry. I said that backwards. Is 660 less than 740? Yep, it is. So I need to scooch Anna over into that slot, which is what this line is doing. And then I'm going to decrement J. So I just wanted to point out that what this while loop is doing is it is performing that shift, but it only works because we first incremented num entries if we needed to. If we didn't add anybody into the board, then we wouldn't actually need to increment num entries because we would want to start at 7 in that case. So that's like maybe a little gotcha there, but it's something that we wanted to do. So yeah, in this case, we would move Anna over, we'd move Paul over, and then when we made this check, is board at J minus 1, so is board in my slot 1, is the score of that less than my new score? No, it's not. Rob's score is 750, and so my while loop would stop, my J wouldn't get incremented, and I would put Jill in at that slot 2. Are there any questions about that? Yeah, sorry about that. So, this is available to you, and what I wanted us to do next is, okay, let's think about, let's say we added Jill, but we realized that, oh wait, no, we should have, Jill cheated to get that score, we need to remove her. So let's say we want a method, remove, that will remove, the purpose of this method is to remove an entry stored at index I in the array, or remove the ith player, right? Or not really, the I plus 1th score. The I plus 1st score. So if I said remove, for Jill, let's go back to our, if I wanted to remove Jill, because after this, let's see, this is our board afterwards. If I want to remove Jill, I want to remove the person in the second slot. So I guess it's actually I minus 1th score. Okay, so let's say I wanted to do this. So this is mostly implemented for us. Why? Can anybody tell me what this exception is telling us to do, or why we have this here? What case is this handling? Yeah. Yeah, exactly. So if we get a negative number, or we get something that's bigger than, not even bigger than the array, just bigger than the number of entries that we have. So say we're in the case that we're in right now, and we have 5 entries, and I call remove of 6, then that doesn't really make sense. There's no score in slot 6, so I shouldn't be able to call it. So that's why we're throwing that this exception here. Then in the code that we have right now, we first grab, okay, so we said, so I guess we're also going to not just remove this, we also want to return it. So, okay, that's easy enough. It's easy enough to return it, right? I just need to return temp, because temp, if I want to get Jill's entry, she's in entry 2, well, that's just board at 2, so I can just return that. So that's happening right there. What else do I need to do? I need to decrement number of entries, right? If I'm removing someone, I should decrement the number of entries. So there, that's happening there. I should set, another thing that's being handled already in the code is that in line 40, again, if we go back to our picture, so suppose we do remove the element at slot 2 in our array, well, at that point, whatever's in slot 4 should be changed to null, right? Because I've removed one, I went from 5 entries to 4, so whatever was in slot index 4 should be null. But now, what has not been done yet is to move the board entries up, right? So in order to implement this, which I will give us 10 minutes to do on our own time, let's first, well, one thing I want to point out, so definitely use this example to your benefit, but one thing I'll point out is when we were adding someone, when we added somebody, we moved to the right? But when we remove, we're going to have to move, I'm going to need to move 3 to the left, and I'm going to need to move 4 to the left, right? Does that make sense? So I'm going to have to move things to the left. So feel free to partner up or just work on your own. I'll give us, let's say, 5 minutes, and then I'll check in, maybe give us another 5 minutes after that. But the task is to try to finish off this remove method. Yeah. The picture, yes. yeah, I don't know. Whichever. Do you have a preference of which one is up? Yeah. Okay. Yeah, and so this, if you pull down the scoreboard.java file from the website, it already has this to do in it. So it's got everything but the to do. So you should be able to start from there. Definitely consider talking to someone.
Yeah, I got it. I had all done. So, yep. You're trying to completely remove from the payment tree, remove oh, you're good. I came prepared for something different today, so okay. Yeah. Oh, there's the movement side. Yeah. So basically,
Like, I feel like, yeah, we kind of need, so let's look at the example here. So we want to put, does it make sense that when I add in this Jill 740 entry, it should go between Rob and Paul? Because it's, 740 is less than 750, but more than 720. So we want to put it in there. So now what we've done is we've got this value num entries, and that tells us, that gives us, well, it's been incremented. So that tells us, that puts us at the end of our, of all of our scores, right? So that's pointing here.
So why is it at 5 and not at 4? Or 4 is no?
Oh wait, it is at 4 actually.
Okay.
Yeah, thank you. So that puts us here. And then basically what we do, so J starts at 4, and then we say as long as board at J minus 1, so J minus 1 in this case is 3, board at 3 is the Anna 660 game entry.
So num entries is 4.
Yeah.
J is 3.
J is 4 actually, because we incremented num entries first in this case.
So
num entries is 5 because it was 4, but we did num entries plus plus.
okay. One over.
Then okay, so num entries is 5.
Okay.
Num entries minus,
J
so
4.
J is 4.
Okay.
But the point is that J is such that the current lowest is 1 to the left of J. And so we go
J
into
is greater than 0 and board of 3 get score is less than new score.
So new score is Jill's 740, right?
Net score.
So now I compare. Is 740 is 660 less than 740?
Wild then shifts these two over
Then it shifts this one over.
by doing board J is equal to
Board J minus 1. So it said board at 4. Now board at 4 points to Anna instead of null.
Okay.
And then we decrement J, so J minus minus, sorry.
Nice.
And now we do the same thing. We look at Paul. Is Paul less than Jill? Yep, he is, so I got to shift him over.
Well,
Now we make J 2. And then we compare. Is Rob less than Jill? Nope. So now I'm done. I'm out of my while loop. And then I set board at J to Jill, because E was my thing I started with. Yeah.
So in this case, instead of using game enter E, you want to use int I.
And you got to remove somebody instead of adding them.
Mm-hmm.
So you remove the person at I instead of adding them. But you're still going to have a pretty similar while loop. But instead of shifting
To the right.
you got to shift to the left.
Thank you.
All right. Anybody making progress? Anybody feeling good? Thought something comes up? Anybody want a couple more minutes to try to get it working themselves? Or do we come back? Okay, let's just come back together and get this going. Okay, so great. All right, anybody have any ideas about what we should do here? I guess before I even get there, okay, how am I going to test it? Well, I just want to be able to call s.remove, and we've said that Jill's the one we want to remove, so I'm going to want to call that. And I always like to start with code that runs, and actually the code that you started with does run. But let's see, did it work? What did it do? Let's take this out. So what happened? When I ran what we have, it looks like I just removed, I didn't remove anybody, right? Because I didn't run it. I think if I look at what we have here, it looks like to me like we're just going to set the last one to null no matter what. That's what our current code is doing. Let's double check that. And indeed, yep, so right now what it does is just removing Anna, but how do we change this code so that it doesn't remove Anna, instead it removes Jill? Okay, so I saw some people who thought that they had a solution here, so let's hear it. Yeah, go for it.
So I made a while loop where if I is less than the number of people is one, or I equals 4.
So, okay, so you have an I. Oh yeah, we already have I. So, maybe J equals I? J less than, sorry, what did you say? No,
J is less than
J is minus 1. And did you increment or decrement?
No, I incremented in the while loop.
Oh, yeah. Oh, okay. I forgot what while loops were there for a second. So while I is less than num entries minus 1, you do something.
And then for I equals 4i plus 1.
Okay, so yeah, so we're starting, if we go back to our picture, as I always like to do, so our I is starting at 2, right? So let's maybe even delete some stuff. Okay, so our I is starting at 2, and yep, we need to move people to the left. And what is moving to the left? It's just setting I, setting board at I to whatever was to its right, right? Great. And I only want to do that until I go far enough. What is far enough? Num entries minus 1. So let's go ahead and test that. And indeed, it looks like it's working. We deleted Jill, and we scooched Paul and Anna over back to their rightful places because we said that Jill cheated. Yeah, any other different solutions or questions? Yeah.
It's really the same idea, I guess, but what if we decrement number of entries and number of entries before the while loop, and then we set, instead of setting forward num entries minus 1 equals null, we do the while loop until I is less than 1 times the length of the board. So I go through the entire board with the number of entries.
So wait. Yeah, I guess you're saying we can keep walking over it, and it's okay if we move a null into a space. One thing that as you're working with these things, one thing that we always have to avoid is trying to access. So I don't think I followed well enough to know whether your solution would have this problem, but as we're working with arrays, we always have to make sure that we don't ever try to call, what happens if I try to say board at 8, dot get score or something like that, or whatever, assign to it or anything like that. What am I going to get? Yeah, an array out of bounds exception, right? I don't have that. So that's one thing that you're going to have to think about, is making sure that you don't access parts of your array that don't exist. Cool. So, yeah. Yeah. So, I don't know. I think, yeah, double straight lines is or, and 2 ampersands is and. And I do know that there is sometimes a difference between performing a bitwise and or a bitwise or, and so that could be something to do with the doubles and the singles, but I am not sure in Java, and that's kind of fuzzy in the back of my mind. So, yeah. Great. So let's move on to another fun topic, which is sorting. So I think, so we will talk more about sorting algorithms later in the class, and we'll formally learn, how do we analyze their runtime, what kind of makes one algorithm have a different runtime than another algorithm, and sorting is kind of like the classic thing that you learn about to demonstrate that. So we'll learn about more efficient sorting algorithms later, but for today, we're going to talk about insertion sort. And I really like insertion sort because it's how I sort cards in my hand when I have, when I'm playing a card game. You pick up your cards, and a lot of times you want your cards to be sorted. And what you do, at least what I do, and kind of generally, is I look at the farthest left thing in my hand. So, for example, we can see, say I have an array of characters. I start with the farthest left, and then I just go 1 to the right, and I say, okay, I got an 8 of hearts, and my next thing is a jack of clubs, and I want to I want to sort my cards both by suit and by number. So I just move left to right, and I pick up a card, and I put it in the right spot. And then I move to the next card, I pick it up, and I put it in the right spot. And that's what insertion sort does too. So for example, it's not getting any bigger, is it? For example, as I'm walking over this array, well, BCD is already sorted, but then when I get to the A, right, it was BCDA, this A, when I pick up that card, I know it's got to move to the front of my hand, right? And so what happens? Well, A just gets moved to the front. Similarly, okay, great. A, B, C, D was sorted. E is also in the right spot. That's awesome. H is also in the right spot. But then once we get to G, E, A, B, C, D, E. Oh yeah, G needs to go before H. Great. So we pick it up and we put it in the right spot. Does that make sense, what insertion sort does? Cool. So we can write this in Java, and in fact, we already have it. And what I wanted to use this for, partly just to give you the insertion sort code to play with, is also, let's put this in here. I think I already have it. Okay, let's run this. We can see, all right, this is doing exactly what that picture did. We started with an array of characters that's unsorted, and we ended with an array of characters that is sorted. Awesome, it's working. But in order to understand this code, it's really nice to be able to visualize what it's actually doing. And one tool that I like for this is this Java tutor that is available online. So if you paste your code in and then at the bottom you press the execute button or something like that, it keeps your code here. That might be a little, let's see. So we've got our code there on the left. Let's make it even bigger. And what we're able to do is step through here. Oh. Maybe I should not have this one. I'm not sure why this is not working. Okay. So ideally, you don't get errors in your code when you bite. Oh, okay. Okay. So now that I removed my package that doesn't really make sense to put in here, I can step through my code and I can see the data on the right here. So here, this little line is pointing to the line 18. That's where, can anybody tell me why does our program start on line 18? Yeah. Yeah, because we always just run the main function, and the first line of our main function is defining this array called our array, and it's this BCD, etc. that we saw. So when we run this by pressing next, we can see a visualization of what actually is being stored in our computer. So we've got that variable our_array, which is actually a pointer to the start of this array, which is holding these characters. We've also got this might be too small for you to see, but even what are the indices of the array? Super nice. Okay, and so now, because we, I must have gone forward a lot actually, because, just to make, hopefully this isn't confusing. Okay, so we run that first line. I don't know why, but it's jumping ahead 9 lines. But in terms of visualizing what's going on, I think that's fine. So we've jumped into insertion sort, which we called on our array, right? And so now in insertion sort, we defined the variable n to be the length of this array that we passed in. So great, n was assigned the value 8. That's awesome. That makes sense. And then now, I really hope it doesn't jump around again, because it could be that I'm just really not good at my new laptop and I can't press only once. But great. So now on this next line, oh, no, it did jump, huh? Okay, great. So now we've got this for loop, and this for loop is going to start from 1. Any guesses, thinking about how we defined insertion sort? Why are we starting from 1 and not from 0? Yeah, we don't really need to move that first element. It's already, by definition, it's sorted, if we're just considering that side of the array. Or similarly, like if I think about my deck of cards, I don't need to, or my hand of cards that I want to sort, I don't need to move my first card. I just look at the second card and I say, does it need to go, do I need to move it or not? So you're exactly right. That's why we start at 1. So this is our outer loop of that sorting process, right? Where we say, okay, I'm going to look at the second card, and do I need to move it? Then I'm going to look at the third card, do I need to move it? So that's that outer loop. We also have the inner loop, is this while loop, and this looks a lot like that while loop that we used for our, the like adding and removing, right? We're making these checks of comparing one thing to another. So that's the inner loop as well. Let's see. So we have our current character that we're looking at. So what is that? That is the first one here. I think I need to execute that. Yep. So current, the variable current is holding the value c, right? Because we're looking at this c and asking, do we need to move it? Did I jump a bunch? Previous, no. Oh. All right. And then for this inner loop, oh, well, we're not, so why, okay, I guess as I'm pressing here, I keep jumping back up. Can anybody tell me why I keep jumping back up in a way? Yeah. Yeah, but exactly right. We're executing this for loop a bunch, this outer for loop, but actually for these first couple letters, we don't actually even go into the for loop, right? Because this first statement is not true. Like, I don't need to move, I don't need to move the C, we're already sorted. I don't need to move the D, it's already sorted. But eventually, we do need to go into our inner loop, which is saying, so what was the first time we had to go into our inner loop? It was when our current value was assigned the value A, right? Because A is the first one that we actually need to move. And so here we are in the inner loop. So current is A. And K was our variable for keeping track of our outer loop, right? K is 3. Inside this loop, we set J equal to K, but now this while loop is going to decrement J until we've found the spot for A. So let's see what that looks like. So I go to the next line. Indeed, J was decremented. I go to the next line, or like I execute again. I execute my while loop again, and J is decremented again because I still haven't found the spot for my A. I run another line. J is now 0. And I finally, now that J is 0, I have finally found the spot for my A. And so I put A in, and we've executed that inner loop. And we've moved J to its spot, yeah. The yeah. So it can compare characters, basically. It's probably, my guess is that it's comparing the ASCII encoding of the characters. So remember, characters are these primitive data types. So they're actually storing some value. And for characters, it's storing the number that corresponds to that value, and the number that then means A, like capital A, is a smaller number than the number that means capital B. So that's how it's comparing them. But yeah, good question. It's like, I mean, the other thing is, I want to point out, like, this is only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like, we've only got about 10 lines of code here, but a lot of stuff is happening. We're moving these letters around, and yeah, we can be pretty concise. Part of that is because we can just directly compare letters, but yeah. So yeah, I think that a resource like this is really nice to visualize your code executing. Yeah.
You briefly mentioned like ASCII, uppercase specifically. If these were a mix of like uppercase and lowercase letters, would the Java still be able to recognize it?
I am not sure. You might get something weird, and that would be my guess is that you wouldn't necessarily get the result you expect, and so I would look